All right, welcome Math 2 students. Here we go. We've got our task 2.8 where we were on this number 8. We did some of it in class and we kind of had to rush through it, so I apologize for that, but I wanted to give you a little extra support so you can get through this. So what we have here is we're factoring something in ax squared plus bx plus c form, and a is now greater than 1. So when it was 1, it was that mother function shape. It was a little bit easier, a lot easier actually. So this time we have a 3 out in front. Now you did see some in a previous part of this task where you could factor out the 3. We don't have that situation. Here's an example of what I mean. If you had a 3x squared plus 15x plus 18, you could factor out the 3 first. And then once you've done that, you've got the mother function shape in here. That 1 makes this super simple to just go find, the numbers that multiply to get 6, that add to get 5. So, okay, so that's a different story. So we had a 3 out there in front of the x squared, but that's not the same type as this. Now you don't have the 3 to factor out in every term. So instead, what we can do is just kind of guess and check at it, which, because this is prime and that's prime, it doesn't take much. So we'll go ahead and do it that way first, but then I am going to give you a technique that gets you through it every time, and there's virtually no guessing and checking. So because it's a 3, we can make this decision pretty quickly. It's got to be a 3x times an x, because if you don't have this 3, you're just going to get an x squared. But that's not true. We do have a 3 here because we need it. We need 3 times 1 to get a 3. All right, next we have this 5 right here. We need to multiply something times something to get a 5. And they're not supposed to add to get 16 this time because there's a 3 out front. But what we can do, we can try the 5 here. We'll try the 1 there. Everything is positive, right, in the whole trinomial. So we'll just put a plus and a plus. It has to be a pluses. Now let's try this out. So we got 3x times x is 3x squared. We've got 3x times 1, that's a 3x. And then we got a 5 times x, which is a 5x. And then we got a 5 times 1, which is a 5. So I like the 5. Now the 3x and the 5x, do those add up to 16x? And the answer is no. So we're not digging this. It's not fitting. So what it looks like we need to do is change the 5 and the 1. So let me back this up. Almost there. Oops, pressing the wrong button, sorry. Here we go. All right, so let's put the 1 here and then the 5 there. You still get the 3x squared right there. You still get the plus 5, so these guys are still good. But now what you've got is a 1x in the middle and a 15x out here on the outside, and those definitely add up to 16x. So there you have it, we found it. All right, so a little guessing and checking and you can get through it. What I'd like to do now is show you another technique for this that works every single time, and there's no guesswork. Now when these numbers get bigger, this 3 is like a 4 or a 6 or something more challenging. There's no guessing. You just do what the routine says to do. So I call it the diamond. Some people call this the magic X or whatever. But the way it works is you're going to put A times C up here. And then we're going to put B down here. So A times C would be the 3 times the 5, that's 15. And then B is this guy right here in the middle, which is your 16. So we need numbers that multiply to get 15 and add to get 16. And there are not many options. So these are the only options. Everything's positive, so it's clearly going to be 1 and 15. So what we want to do now is we want to break that bx down in the middle here with the numbers you found over here. Let me say that again. Break the bx down with the numbers you found. So what we'll have is a 3x squared plus a 1x plus a 15x and then plus 5. So you'll notice the 3x squared doesn't change. Oh, that's the wrong thing. I learned a pen. Let me do that again. How about some red? So the 3x squared doesn't change. The 5 doesn't change, right? Except for the fact that there we go. But what we got here for the middle term is I'm breaking this 16x down into two terms. And that's what this magic X or this diamond does for us. All right, so next we have, let me change that to blue for a quick second. All right, so I've got two piles here. And each of those piles has a GCF in it. So what we'd like to do is factor out what's in common. So looking at the first pile here, I notice they both have an x. So I'm going to factor out an x. And that's going to leave a 3 times x plus a 1. Let's double check that. X times 3x is 3x squared. X times 1 is 1x. Perfect. Do that a little bit nicer. There we go. Next, this 15x and this 5. What's in common to those? What could you divide out? Well, they don't both have an x, but you can factor out a 5. And it's a positive 5, so we'll put plus 5. And then the stuff left behind would have to be a 3x, because 5 times 3x is 15x. And then 5 times 1 is going to be 5. So this is genius, because now if you look at what we got, these two piles, they both have something in common as well. And if you notice, the something they have in common is actually this really fancy thing. It's the 3x. Oops, I'm going to change that to a highlighter. So let's go like this. That is in common to both piles. And then my leftovers, or my left behind stuff, will be this x plus 5. So what we're going to do is we're going to take, oops, still learning how to use this notepad here. Getting better, but it's taking some time. Okay, so what we're going to do is factor out the 3x plus 1. So that goes here. And then the leftovers, I call them the leftovers, the blue things, those will go over here. And there we have it, same answer. Okay, and you might be looking at this going, wait a minute, that's a lot of extra work. I didn't need to do all that. And you're probably right on this one. But when the problem gets tougher and the numbers are bigger, or there's more options, like a 4 over here, it could be 1 and 4, or it could be 2 and 2. Put a 6 over here, now it's 1 and 6, or it's 2 and 3. How about a 24? You got 1 times 24, then you got 2 times 12, and 3 times 8, and 4 times 6, and lots of options makes it more complicated. So let's go ahead and try this new technique on part B. Oops. So let me draw a little line here, separate. Here goes part B, and it's a 2x squared minus 13x plus 15. So the first thing I notice, let me copy it down. First thing I notice is there's no GCF, right? Nothing's in common to all three. So I'm going to go ahead and multiply the A and the C. So the 15 and the 2 there. That's going to be 30. Now pay attention to the signs. If it's one of each sign, you'll make it a negative 30. Okay, down here we got a negative 13. So I'm thinking about my numbers. I notice that they have to multiply to get a positive 30, but they have to add to get a negative. So they're going to have to be both negative. So negative 1 times negative 30. I'm just making a little list here. These are all the factors of negative 30. And I'm keeping with the all negatives because it has to be all negatives. These guys add up to negative 31. These guys add up to negative 17. These guys are perfect. These guys don't work. So it'll be negative 3 and negative 10. And you get to choose where to put them. It's up to you. Okay, it's time to break the bx down with the number you found. 2x squared doesn't change. It's beautiful. Then we got a minus 10x. Then we got a minus 3x. Then we got a plus 15. Okay, so we just broke the bx down. Nothing changed here. Nothing changed here. Just break the bx down with the numbers you found. Make sure you have x's in here. Okay, so it's time. It's time for us to decide what's in common there, and then what's in common over there. So let's do that. I see a 2 goes into both of these, and they also both have an x. So let's pull an x out as well. And that leaves an x here because 2x times x is 2x squared, and then minus 5 because 2x times negative 5 is negative 10x. All right, so next, you don't want to have a negative inside your parentheses. You're never going to have this. Okay, you don't want to have a negative in there. So in order to keep that from happening, we're going to make sure we pull the negative out. So we'll go minus something. Now what's in common to the 3 and the 15? And I'm hoping you're thinking 3. Once we do that, you leave an x minus 5, because a negative 3 times a negative 5 is a 15. Now this is not magical. This is going to happen every time. I guess you could call it mathemagical. These two piles, they're both going to have an x minus 5. If the diamond works, you will have the same exact parentheses here. All right, so let's go ahead and factor out the x minus 5. And then the leftovers, let's do a little highlighting. Here's my leftovers, that guy and this guy. So that's going to come out. Will not come out. It's going to stay inside the other parentheses, we'll say. And there is your answer. You can double check it. X times 2x is 2x squared. Got it. The last terms, negative 5 times negative 3 is positive 15. And then your middle terms, that would be a negative 10x and then a negative 3x, and those add up to negative 13x. So we got it. Our answer, let me clean that back up a little bit. That's perfect right there. We did it. All right, here we go, part C. This time I'll go a little bit faster. I'm going to fast forward here. We'll just write it over on the right. 3x squared plus x, and then we got a minus 10. And we'll go ahead and pay attention to the fact there's a 1 right there. All right, so there's nothing in common to all three of them. So diamond goes like this, 3 times negative 10, negative 30. Adding to get the 1 that wasn't showing, but we put it, shine the light on it, and we can see it hiding in the shadows there. And then we got to have one of each sign here. So I'm thinking 1 times 30, 2 times 15, 3 times 10, 5 times 6. This is looking good. If I needed to, I could keep going and then switch them, right? Switch the signs. So it's negative 5 and a 6. All right, so here goes. Let's break the bx down with the numbers you found. Now when you do this and you have two different signs, I always put the negative one first. It makes it a little bit easier on our brains. I'll show you why in just a second. So break the bx down with the numbers you found. So this became this right here. Okay. So 1x becomes negative 5x plus 6x. All right, so next up, we have two piles. That pile, that pile. Whichever one is easier, you can actually factor whichever one's easier, and then you can cheat off of your work and do something similar on the other. I'm going to go with the 6x minus 10. I see that there's a 3 that I can factor out. Oh, excuse me, a 2 that I can factor out. And that's going to leave a 3x minus 5. And if you look over here, this has a 3x minus 5. I'm pretty sure that's going to be a 3x minus 5. Let's cheat and just copy that over there. And that means I would have pulled out an x over here, because x times 3x is 3x squared, and x times negative 5 is negative 5x. And we've got it. Now the other thing I showed in class is you could break this down like so. Break it down into prime factors here, and notice there are no numbers in common, but there is an x in common. So the x comes out, and the leftovers 3x minus 5 stay inside. All right, so these two piles, they both have a 3x minus 5. Leftovers over here, and we are done. You can always check your work. You can do a little box or whatever. I mentioned how I was going to show you what happens if we had put these in a different order. What if you put plus 6x and minus 5x minus 10? Well, now when you factor, let me change this thickness here. There we go. So when you factor this time, you're going to get a 3x and an x plus 2. And then you have to factor out a negative from this guy, which is not that hard, but you know, if we can avoid factoring out negatives, I'm going to do that. So there we go, negative 5x minus 10. Okay, so my common factor is x plus 2. And then we got our leftovers, 3x minus 5. And that, my friends, is the same as that. And again, we've talked about this for a few days now. The order does not matter. Okay, as long as 3x minus 5 is in there and an x plus 2 is in there. All right, I think that's probably about it. There is a part D there if you want to try that out. You don't have to, but this should help you get through your homework. I will say you can skip all of this if you can just look at this and start telling me, hey, it's got to be a 3x and an x, and then try to guess some things. Is it a 1 and a 10? Or is it a 10 and a 1? Or is it a 5 and a 2? Is it a 2 and a 5?